Here we are asked several questions that follow on from the previous video. Firstly, we must identify the specific type of elimination reaction occurring in the third reaction. In an elimination reaction, a small molecule is removed or eliminated. When a haloalkane undergoes an elimination reaction, a hydrogen atom and the halogen atom are removed. When a hydrogen and a halogen are removed, it is called a dehydrohalogenation elimination reaction. In this case, hydrogen bromide is removed. As a result of two atoms being eliminated with nothing to replace them, a carbon-carbon double bond is formed between the carbon atoms to which the two eliminated atoms were attached. This compound is but-1-ene, an alkene. Next, we are asked to give an equation for reaction 4. The only information we have is that these two compounds, encircled in orange, are positional isomers. Positional isomers are compounds that have the same molecular formula. Both these compounds have 4 carbons and 8 hydrogens. The same functional group, they both have a carbon-carbon double bond, but the functional group or substituent is in a different position in the carbon chain. In but-1-ene, the double bond is on carbon 1, and in but-2-ene, it is on carbon 2. Following the arrow directions, we need to somehow move the double bond from carbon 1 to carbon 2 using the list of available reagents in the question paper. This means we will first need to open up this double bond in an addition reaction and then recreate a double bond in a new position, and this will involve elimination again. So let's look at this addition reaction first and the available reagents. What happens if we added hydrogen gas? The product would be butane. But there is no reagent available to remove 2 of the hydrogens selectively at carbon number 2 to form but-2-ene, so we can eliminate hydrogen. If we added bromine, we would get 1,2-dibromobutane. And if we used concentrated sodium hydroxide, this would remove a hydrogen and a bromine. Then in the elimination reaction, a haloalkene would be left, bromobutene, and not an alkene. So bromine is not suitable. We can eliminate it as a reagent. If we added hydrogen bromide to the alkene, the hydrogen atom would add on to one of the carbons at the double bond, and the bromine atom would add on to the other carbon. It is more likely for bromine to add on to carbon number 2, according to Markovnikov's rule, but it could instead add on to carbon number 1. Then, if we used concentrated sodium hydroxide, we would induce a dehydrohalogenation elimination reaction, where a hydrogen and a bromine are lost, and a double bond is formed, either on carbon 1 or on carbon 2. So hydrogen bromide is a suitable reagent for the addition reaction. The full structural equation for the addition reaction will look like this, where bromine is added onto carbon 2, or like this, where bromine is added onto carbon 1. We are then asked for the equation for elimination, and there are 2 possible answers you can give. One, which produces a double bond on carbon 2, and the other which produces a double bond on carbon 1. Finally, we need the IUPAC name of this alkene. It can be but-2-ene as drawn here, or but-1-ene. The root name or parent name but tells us there are 4 carbons in the chain. The suffix -ene tells us there is a carbon-carbon double bond, and the number before the suffix tells us the lower number of the 2 carbons that the double bond is between.